In this video, we are going to look at how to apply these spreadsheet formulas to savings plans. In this first problem, we're looking at saving for a retirement plan. A traditional individual retirement account, IRA, is a special type of retirement account in which the money you invest is exempt from income taxes until you withdraw from it. If you deposit $150 each month into an IRA earning 3% APR, how much will you have in the account after 25 years? How much will you have earned in interest? What percentage of the balance is interest? This problem is asking us to do three different things, and so we're going to need to break it down into pieces to look at. So the first thing we'll look at is the first question here. The first question says, how much will you have in the account after 25 years? So this is telling me that maybe I should look at using the future value formula because it's asking how much will I have in the account in 25 years, not how much do I have or should I have, that kind of thing. So I'm not looking at what I need in the present time. I'm looking at what I need in the future. So this is going to need the future value formula. For the rate, we need our APR and we need the number of compounding periods within that APR. In this case, it says our APR is 3%, and it doesn't really tell us anything specific about compounding any particular time period, but it does tell us that we're making a monthly payment, which is a hint that it's going to compound monthly. So our N is 12. So I'm going to write on the side here that our rate is going to be 0.03 divided by 12. The next thing we need is the number of periods. And to get that, we need to have our N, and we're multiplying it by the number of years total, which in this case is 25. The next thing we need is payments. And for all the problems we've looked at so far, there have not been any payments, but this problem actually says we are going to deposit $150 every month. And so in this case, we actually do have a payment. Our payment is $150. And the last thing we look at is present value. We are not starting with anything in our account. It does not mention that there is anything in the account yet. So our present value is going to be 0. So now that we have all of the information filled out, we can go ahead and put it into our formula, and then we can plug that into our spreadsheet and get our final amount of what will be in the account in 25 years. So that's the first thing it's asking us to do. The next thing it would like us to do is to determine how much will be interest within that account. So how much will we have earned for interest? Now, this is the amount that's in the account at the end of 25 years, but this amount is not all interest. We started with $0. We had to put money in the account in order to actually earn interest, and that was the $150 every month. And so we need to determine how much money did we actually put into the account. So to figure out how much we paid into the account, we're going to take our monthly payment and multiply that by the 12 pay periods within a year, and then multiply that by the 25 years. This tells us how much money we put in the account over 25 years, which means out of the $66,901.17, $45,000 of it was paid into the account by us, and the rest is the interest we earn. So to figure out the amount that is interest, we're going to take the total amount in the account and subtract the amount we paid into the account and see how much was earned in interest. The last thing it asks us to do is to figure out what percent of the balance is interest. To do that, we're going to take the amount of interest earned and divide it by the total amount in the account and turn that into a percent. We earned $21,901.17, and there's a total of $66,901.17. To turn that to a percent, we just multiply by 100, and we'll put that in a calculator and get that it is just shy of approximately 33%. The next example we're looking at is going to require us to add a spreadsheet formula to our list of spreadsheet formulas. This one is the payment formula. So we've looked at future value and present value, and now we're going to look at payments. It says you want to have $1 million in your account when you retire in 30 years. Your retirement account earns 7% APR. How much do you need to deposit each month to make your retirement goal? So in this case, we have a goal that we want, and we know how many years we want to take to reach that goal. We don't have a current amount that we want to pay. We don't have a present value we want to make. We want to try and reach our goal by making monthly payments. So in this case, we're going to use the payment formula. As we did for the others, we're going to pull out the information we need. We're going to need our interest rate. We're going to need the compounding period, which is 12. We'll need the number of years and the principal or the present value. And in this case, our present value is going to be 0. We don't have a present value, but we do have a future value. That's that $1 million that we want to make. So let's go ahead and fill out our rate and our number of periods. And now that we have all of our information, as before with the other formulas, we can go ahead and fill those out into our spreadsheet formula itself and put that into our spreadsheet and get that if we make $819.69 each month for 30 years, we will have $1 million in our account